For Physics 102A, here are the solutions for Chapter 11. This first video will be for numbers 15 through 23. So for number 15, frequency is 0.40 hertz. The wavelength lambda is 2.0 meters. The question is asking what's the velocity. So we use the equation v equals f times lambda. Velocity is frequency times wavelength. And then plug in those numbers. Notice that I've turned frequency, instead of saying 0.40 hertz, I've turned it to 0.40 per second, and that's appropriate because hertz is cycles per second. So the units, dimensionally, this is going to end up in meters per second. So the answer is 0.80 meters per second, and that's answer D. Number 17, the question is asking about changing the amplitude, what happens to the wavelength? Well, we in class didn't actually discuss amplitude too much, but what you should know is that wavelength has nothing to do with amplitude. Amplitude has to do with the volume of the sound, the amount of energy, but it has nothing to do with the wavelength. So wavelength remains constant, and it's B, 2.6 meters. Number 19, this one wasn't assigned, but in case you wanted to tackle it, it's asking how many antinodes are on the third harmonic. And just draw pictures on this. So the first one, as I've drawn for you in class, just like the slinky that we demonstrate in class, there's the fundamental, or the first harmonic. The second harmonic is going to have 2 of the antinodes, and the third harmonic is going to have 3 of the antinodes. So the third harmonic has 3 antinodes. The last one for this video is number 23. It's asking about the Doppler effect. So we have that the velocity of the source is 20 meters per second. Its frequency is 1.13 kilohertz. There are 4 equations that you have. As of this recording, I've only given you 2, when the source is moving either toward or away from the observer. On Monday after this recording, we'll discuss in class when the observer is moving away from the source. But this is the equation, that the perceived frequency, f prime, is the emitted frequency divided by 1 over velocity of the source divided by velocity of the sound. So as we plug the numbers in, notice it's good to pay attention to the units. I don't have to convert this to hertz, but recognize that those are the units that I'm using. So 1.13 kilohertz is the emitted frequency, divided by 1 minus, and then we plug in velocity of source divided by velocity of sound, 20 meters per second over 343. As you plug in those numbers, notice that in the denominator, the meters per second and the meters per second will divide out, so the denominator becomes dimensionless, 1 minus 0.058309 approximately. Therefore, our total answer is still going to be in kilohertz, because we started with kilohertz. And so we have 1.13 kilohertz divided by 0.94 roughly, and that gives us a perceived frequency of 1.20 kilohertz, which is answer B. Then we should go back and reflect on the answer and see if it makes sense. The question says that the source is moving towards the observer. Our intuition tells us if the source is moving towards us, there's an increase in frequency. So as I look back and evaluate this, there should be a higher frequency perceived. And the answer given is 1.20 kilohertz, whereas the original frequency was 1.13 kilohertz. And that fits with what I intuitively know, that the frequency should have gone up. That's it for this video.